Hi, buddies. Today we will start the equivalence of PDA and context-free grammar. That means a PDA is given to us, and now we have to find the context-free grammar corresponding to the PDA. So, if a PDA is given to us, that means a transition function is actually given to us, because transition function shows all the transitions of a PDA or a machine, right? So now we have to convert the transition function into the production rule, because the production rules is the main entity of the any grammar. Means the execution of grammar can be explained, can be discussed with the help of the production rule. So simply we have to convert the production transition function into the production rules. So now you can see here, uh, how can we find that? So simply we have to construct a grammar in this way. You can find that is the grammar can be represented by four tuples. We already know this. So the tuples can be variable v, terminal, that is sigma, p, that is the set of production rules, and s is the start symbol. So these are the certain rules to define the all these tuples. For example, start with the set of variables. So variables can be considered or can be defined with the help of the PDA or given PDA. That is S start symbol union Q Z Q dash, where Q and Q dash belongs to Q. So Q is what? Q is the set of state, and Z is what? Z belongs to tau, that is the stack symbol. So this is the simple rule to write the variables for the grammar. And now after that, we will try to write the rule number 1 for writing the starting symbol as productions. So start symbol S can be written as S2 Q0, that is the initial state, Z0 initial stack symbol, and then Q, where Q belongs to, for all Q belongs to capital Q. That is the Q is what? This is the set of states, right? All the states of that belongs to capital Q. So in this way, this is the rule to produce, write the production rule. Now the important point is, how can we write the production, how can we write or how can we convert the transition function in the form of production rules. So now the important entity is just the production rule. So here, suppose this is the case of erasing the push down symbol. That means if suppose you are reading from symbol, you are pop out the symbol from the stack, and you are not pushing anything into the stack. So this is the simple process that you can say, or simple operation that you can say, that is the erasing operation, right? So in this situation, what we have to write, that is the, suppose transition function is given to you, that is delta q a z is equals to q dash null, means you are not pushing anything into the stack. So such type of transitions can be converted into the production rule as, that is q, that is this one q, and z, this one stack symbol, q dash, this is the new outcome state, and finally you have the terminal, that is a. So this will be reflected in this way. So if this type of transition function is there, then we should we should convert it into the production rule in this way. So this is the rule number 2, that is associated with the erasing the push down symbol. Another part is, suppose we are pushing the symbols into the stack. Means in this case we are not pushing anything into the stack. But if we are pushing anything into the stack, that means suppose you are reading Z from the you are popping Z from the stack, and after the transition you are pushing Z1, Z2, Z3, Z4, because we can push any number of element into the stack, right? We have already know this thing. So in this situation, what we have to do, so in this situation you can write the transition as q z, and outcome state, qz, that is the a is the terminal, that is always we should write here, and new state is the q1, so just write here, right? And then how many symbols you are moving into the stack, you are pushing into the stack, so just write 1y1 in this way, right? So this is the simple rule for pushing the element into the stack. So now just we will try to give some trick. How can we write here Q1, Q2, Q3, because these are the states up to Qm, right? So just with the help of the example, we will discuss it more detail. So suppose this PDA is given to you. Now you can find here, these are the transition function for the PDA, and this is the complete representation of PDA. So in this case, you can find here the total number of states used in the PDA is EDR Q0 Q1, terminals A comma B, Z0 Z. These are the tau stack symbol, transition function, Q0 initial state, Z0 initial stack symbol, and phi is the by using the null store. So now we will explain one by one how can we apply the rules. So just we will start with rule number 2, that is the erasing push down symbol. Means you are not pushing anything into the stack. These are two cases you can find by number 2 and number 5. In this case, you are not pushing anything into the stack. So now how can we write these two production rule in the form of PDA? Just see here. This is the case. You are not pushing anything into the stack. So just how can we write it? This is the Q0, Z0, that is the stack symbol. And here you are writing the next state, or you can say the outcome state. It may be changed, maybe Q1, Q2, maybe Q0, whatever, right? And finally, what you are going to produce means terminal, or the terminal is always read from the input tape. So that terminal will be in that place, right? So simply this is the production rule of corresponding to the transition function. Similarly, Q1 BZ, Q1 null, this is another transition function. And now our objective is to convert this transition function into the production rule. So how can we convert it? This is the state where your machine is going to start. This is the stack symbol. Now outcome state, that is the Q1, right? And here again, this is the place, simply this is the place of symbol that you are reading from tape. So this is simple reflected here. So with the by using rule 2, just we can convert the transition function into the production rule, right? So how can we say that this is the symbol you are reading from tape? Because at the time of writing the transition function of PDA, this is the place of writing the state. After that, this is the place of reading the symbol from the stack, that may be A, B, C, whatever. And after that, this is the place of symbol that you are reading from what? That you are reading from stack. So these are the three tuples. These are the three parameters that you have to pass at the time of performing the transition. And after that, you are moving to new state, that may be same state. And then here you are writing the symbols that you want to push into the stack. Suppose you do not want to anything into the stack, then in this case you just write here null. So null is basically the case where you don't require to push anything into the stack. So in this situation, we can convert all the transition function into the production rule. So now another part is rule number 3. This is the important part here. You can see here it is defined that you are pushing something into the stack. Before, rule number 2 is applied where you are not pushing, you are erasing the symbol basically. But rule number 3 is applied where you are pushing some elements into the stack. So how you can apply this thing? Just see here. In this case, suppose this type of transition is there. So how can we apply? Just see here. This is suppose Q0, B is the symbol that you are reading from input tape, and Z0 is the stack symbol. Now you are in state Q0 and you are pushing here Z0. So these are two symbols that you are going to push into the stack. So this type of transition function can be written in the form of production rule in this way. Just see here, this is the Q0, this is the stack symbols just written in the same position. Just try to blank this position, and now this is the terminal that you are reading from tape. So just move to this position. After this, you are moving to the Q0 state. So just write here Q0. Now it is noted that here you are going to push two elements into the stack, or two symbols into the stack. So symbols are Z and Z0. So just push Z at one place, and another place you should mention only Z, right? So now just you should calculate how many symbols you are going to push. So here it is clearly defined that Z and Z naught, these are two symbols that you want to push into the stack. So in this case, how many production rules will be possible? So there may two symbols are pushing. You want to push two symbols. That means 2 to the power 2. That means 4. So now 4 production rules will be there, right? And total number of states are Q0 and Q1. So simple, just try to find the combination of 4 by using Q0 and Q1. So just in this place Q0, Q0, and 4 combination will be Q0, 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 Q1, Q1, Q0, Q1, Q1, right? So just this value will be copied here, and the last value will be copied to the this place. So this is the simple way, simple trick to convert transition function of pushing the element into PDA to the production rule. So on the same way, you can find here Q0, Z0, and this place is empty, B, Q0, Z, and here Z0. So just here start with Q0, Q0. So this Q0 is copied to here, and Q0, this one is copied to this place. Similarly, 10. So in this case, Q1 is copied to this place and Q0 is copied to this place. This is 10 in this situation. Q0, this is copied to the here, and Q1 is copied to here. And finally, Q1 is copied to here, and Q1 is copied to here. So this is the simple rule, rule number 3, to convert the transition function of pushing the elements into the production rule, right? So now, if suppose there is only one element that you want to push into the stack, in this situation, what will happen? Just see here. In this is the simple case where you are pushing only Z. So this is how can we find the total number of iteration, total number of production rules? That is one symbol you are going to push. So 2 to the power 1, that is 2. So now you will have to write two rules, two production rules as per the given transition function. So how we can write it? Just copy here Q0. This is Z. This A will be reached to here, and just keep blank this position, right? And then Q1 new state, that is Q1 Z. Only Z is there, right? So only one symbol is there. So if one symbol is there, then 2 to the power 1, that will be two possibility. Now two states are Q0 and Q1. So and the first time you can put Q0, and the another time you can put Q1. So first time we put here Q0, and another time we put here Q1. This Q1 is last one is already copied to the this place. I already told you in the previous case. So just copy here Q1 and just copy here Q0. So the same transition function can be converted into the production rule, right? So this is the same way. Q0 is pushing here. So this is the total 1. So total 1 symbol is pushing into the stack. That means total production rule will be 2 to the power 1, that is 2. So just write Q0 one time, another time Q1. Just copy it Q0, and here copy it Q1. So this is the simplest way through which you can convert the production rules. You can convert the transition function into the production rule. And after that, I suggest you, after that you can write the start symbol, that is S, that I already told you. The start symbol can be represented by this way, that is S can be S2 Q0 Z0 Q, where Q is what? Q is the set of state. So simple, after doing all the transitions, you can mention all these things. So just see here, that is Q0 Z0 Q0 Q0 Z0 Q1. Why we are going to write this thing? Because in this is the only combination, that is Q0 Z0 Q0 Q0 Z0 Q1. And after that you are not finding any other production in this way, that is Q0 Z0, not in any format, that is Q0 Z0, right? So total number of production in the form of Q0 Z0 are Q0 Z0 Q0 and Q0 Z0 Q1. So just we have to write here in place of this start symbol. And after that, the set of variables, just write all the combination of the this states right? All the productions, but it should be noted that the no production will be repeated. So just write all the production here, that is Q0, Z0, Q1, Q0, Z0, Q1, Q0, Z0, Q0, right? So in this way, just you can see, you can check no production, no variable is repeated here. The Q0, Z0, Q1, then no one is here, right? So this is the simple conversion, you can say, find the equivalence, you can say, from a PDA in the form of grammar. So if you have any confusion or doubt, then we will discuss it.